Okay, so problem 2 of homework 9 asks us to show that x and the derivative, so they want us to show that x of t and x prime of t, which is equal to d dt of x of t, they want us to show that these two are orthogonal and uncorrelated, knowing that x of t is a wide-sense stationary process. So, before we begin, we have to recall that the expected value of a wide-sense stationary process is equal to a constant. I'm going to call it eta here. Now, also, we know that the expected value of the derivative of x of t is equal to the derivative of the expected value. And this is because of linearity. Like this. So we know from here, we know that expected value of x of t is just eta, and which is just a constant, and the derivative of a constant is just 0. So we know that the expected value of x prime of t is equal to 0. Okay. Now we want to show first, this is just some background. Now we want to show that this and this are orthogonal. So to show that they're orthogonal, you have to show that the expected value of their product is equal to 0. So let's do that. Expected value of x of t times x prime of t. I'm going to just write it with d dt because for me it's a little easier. So I have x of t, let me put, because these are all a bold face, so I'm putting the vector sign on the bottom. So we have this. Now, what does this look like? It looks like the product rule applied to x of t times x of t. So if we apply the product rule to this, we get 2 times x of t d x of t dt. These are all bold. So we can just substitute this, so I can divide both sides by 2, so I get 1/2 like this, and I can substitute that in here. So we have expected value of x of t times x prime of t is equal to the expected value of, we have the 1/2, I'll just take it out in front, of d dt x of t times x of t. Again, using this property that we showed above, the expected value of the derivative is the derivative of the expected value. So I can take 1/2 d dt of expected value of x of t squared. Well, we know that x of t is wide-sense stationary, so that means that expected value of x squared is simply r of 0. So 1/2 d dt r of 0. Now r of 0 is just a constant, so the derivative of a constant is just 0. So we end up getting 0. So we have proven that they are orthogonal. So yes, they are orthogonal. Now we have to show that they're uncorrelated. Well, we know to show that they're uncorrelated, we have to show that expected value of x of t times expected value of x prime of t is equal to the expected value of their product. I'm sorry, I made a mistake. This is like this. So we know that this is 0, and we know that this guy is 0, and this guy is eta. So eta times 0 gives you 0. So here we show, yes, they are uncorrelated. Uncorrelated. And that completes the problem.